एक एग्जांपल देखते हैं हम लोग इंटरनल फोर्स को इंक्लूड करते हुए, ठीक है। Okay, so consider two objects. Suppose this is mass m is 2 kg. So we are going to consider now system of particles, not only one object. So system of objects. So suppose we have two objects now here, and for this we will verify the work ratio. So mass is 4 kg here, okay, and these two objects are attracting each other with a constant force. So the two objects are attracting each other. The two objects m and m are pulling each other or attracting each other, pulling each other with constant force, F equal to 8 Newton. Okay, so constant force is acting, F equal to 8 Newton. And what we are going to do is initial velocity were suppose 0. Initially the two objects are at rest. Initially m and m are at rest. Okay, so if they will pull each other with constant force, they will acquire some velocity. Okay, so verify work energy theorem for a time of 2 seconds. Okay, so for a time of 2 seconds, we will see, means at the beginning of 2 seconds and at the end of 2 seconds, we will see the work done and kinetic energy, and we will try to verify it. Okay, so time is given. So first we will see what are the accelerations of the two objects. If 8 Newton force acts, if 8 Newton is acting between them, means they are acting upon each other. They are that 8 Newton is internal force. They are exerting over each other, exerting on each other. So acceleration of first object A1, how much it will be? It will be 8 Newton divided by 2 kg. That is 4 meter per second square. And for this one, acceleration will be how much? It will be 8 Newton in backward direction. So acceleration of second object will be 8 by 4 kg. So it will be 2 meter. Acceleration will be in backward direction, that is 8 Newton by 4 kg. So that is 2 meter per second square. Okay. So similarly, we can find displacement. So displacement for first one in time 2 seconds. So half A1 t square. Okay. So t is time. This is time t. So half into 4 into t. So that is how much? 2. So 2 square. So 16 by 2. So how much? 16 by 2 means 8 meters. Similarly, S2 is half A2 t square. So half A2 is 2 into t square, 4 meter. Okay. So this is 8 meter and this is 4 meter. These are two displacements. Now what will be work done by two forces? So work done by two forces. So work done by first force. So first force is acting in the rightward direction and displacement is also in the rightward direction. So they both are in same direction. So 8 Newton for how much displacement? For first object, 8 meter displacement. 8 into 8. So that is coming how much? 8 into 8. 64 joule. Similarly, work W2. So if you see W2, the W2 is acting, the force is acting backward direction and displacement is also in backward direction. Both are in same direction finally. So we can say minus 8 and minus S2 we can say, because both are in same direction finally. Both are in negative direction. So finally we are having 8 into S2 is how much? S2 was 4. So 4, that is 32 joule. Okay, so these are the two work done. So what will be the net work done? Net work done by all forces is how much? That is 64 plus 32. So that is coming how much? 96 joule. Okay. So this is one side of the proof, that is calculation of work done. Now we will see calculation of change in kinetic energy. So what is change in kinetic energy of first particle? So 1. So how much velocity it will acquire after time 2 seconds. So we will see the velocity. So first we write the velocity v1. The velocity v1 will be a1 into time t. So that is a1 is how much? A1 is 4, time t is 2. So that is coming 8 meter per second. Similarly, velocity v2 is a2 into t. So a2 is how much? A2 is 2 into 2. So that is coming 4 meter per second. So now we will write change of kinetic energy for first particle. So half m v1 square. Initial was 0 because initially they were at rest. So initial kinetic energy is 0. So half into m. First object is mass is 2 kg and velocity is how much? 8. So how much we are getting? 64 joule. And similarly for second one, half m v2 square minus 0. So half into mass is m1, this was m2, or capital M, sorry, this was small m and this is capital M. Okay, so capital M is 4 kg into v2 is 4 meter per second. So how much we will have? So 64 by 32 joule. Okay. So you can see that total change of kinetic energy is delta K1 plus delta K2 equal to 64 plus 32, that is 96 joule. Okay. So you can see that total change of kinetic energy equal to total work done. So that is also applicable for a system of particle. Here we saw that this is not just one object.